from Romania. And improve the program. Is not perfect, but is way more better than it was in the beginning. And all it mattered was code optimization, which I did here, exactly what I did here. As you can see, in A, B, C, and D versions for the same LED matrix display, showing letter A only, but these are version A, B, C, D. I know it's a bit confusion, but I should have put version 1. All that I really wanted was to improve the speed displaying the character. All it was, in the end, it was a matter of code optimization, proper use of library functions, and the speed right now that you are seeing is either maximum or very close to maximum, as this Arduino board or processor on the board can deliver. And the better solution to have a bit more speed on this is to use more dedicated ICs like MAX 7219 and HT16K33, which some guys from Arduino forums recommended to use. And I was talking with them, of course, and they were great help because this was a challenging project. Let me present first how everything works to make the comparison. Already, this was the original code, and this was the original code that I did, and it didn't work very fast, and you can see it and upload it there. Now it's uploading, and you can see how slow. You can see how slow is moving. This is the fastest speed of the lines open up as I could make it at the time. I didn't know the library. I didn't read the library. I didn't I didn't optimize the code at all. I didn't think of optimizing it too hard. And this is A, letter A, but the name of the program is the first one. I've also named it as A, unfortunately. And this is B, but it's not letter B, it's version B right now, which is a bit awkward, but yeah, it's the thing. You can see it there in the title. Always look there to see the name of the program. So this is a bit more what I did here. Everything is repetitive, as you can see. Line 3, this is line 4, line 5, line 6, line 7, and that's it. And as you can see, it's only character that I'm playing here. I'm playing with the speed of how the lines will go one after another. And here I don't even remember what I did. I think I put, yeah, I get rid of that reset. Here I get rid of that reset. I had a reset function. Actually, I can show you. I presented last time also. So here in the version A of the program, I had this reset function that was cycling through all the pins and was eating a lot of time cycling through all the pins. And here is the reset function actually calling back to this reset function here and executing it. So this is in version A, and here in version B back, I have this reset function. I commented out. I ignored it, and what I did, a very smart move actually, I've implemented the switch to input from output to input directly per each pin, not through all pins like I did it in the reset function, and I was calling it in the first version. So now if I'm switching, everything is switched to input actually. As you can see here, everything is when is starting in the setup mode. This doesn't matter how much time is taking, so we can use a loop like this without problems. And I also write digital low to ground or to 0 volts, just to be sure. I don't think this is absolutely necessary, but I did it anyway. And here I switched the pins, the first line of A, the top line, this line here, from here to here. This is the first line. Actually, I can show you on the diagram that I have. 1 second. Let's see. I suppose I'm not sure which one I should. Okay. This one. Okay, this one. So this is the pins one. This is the first line where it says 1 here. This is the first line. So all this A, B, C, D, E, of 1. This is the first line. This is the second line. And I actually open only this 3, and then this 2 again, and all the entire line of 4, and then again this 2, and this 2. And this is the lines that this is the code. So everything, as I said, is set as input in the beginning. Is like floating. The pins are floating. They are not positive nor negative, ideally. But in reality, I'm not sure exactly what it's doing. I suppose they are grounded to 0 volts. But I put it to input in, like the pin is floating, and then I switch this line. This LEDs from that line. This is the line 1, it says here, and then line 2, like here, and the code is kind of repeating itself, but some data is changed inside to correspond to those LEDs. So this is I switch to output. What I need, the LEDs that I need. One is representing the line, and then the columns. Like I said, only 3. So these 3. These 3 guys here are the actual LEDs on line 1. That represents number 5. And here is not. This is not good. Here, this is good. So line 1 is number 5, and here 10, 3, and 4 columns. So column 10, 3, and 4. You see, and they correspond actually to B, C, D on line 1. This is what it's doing. By the way, this diagram, I made it after discovering how this module is working. I didn't have anything, and I had to invent one. Also, I imagine I have to put these resistors here, which I switched from 1 kilo to 300 ohms right now. Right now are 300 ohms. And then I switched to high, and the corresponding plus and minus, positive and negative. So I had I suppose, yeah, it's the internal logic that you have to pay attention to know about, which is high, which is positive, which is negative. So this is what I did here. So to open these LEDs, these 3, you have to put to plus number 5 from line A, and rest low. So the columns are 0 volts, and 10 and 3 and 4 are low. So only that one high, and the rest are to minus, to 0 volts. And you can lit these 3 specific LEDs. This is the logic of this particular device that I have here for this grid. And then I'm appealing to a delay, which is this one, which is the minimum of 1. Lower than 1, it doesn't go. So with my logic was like this: with this delay or without this delay of 1 of its minimum, it's like you don't have a delay at all. And I was complaining about the speed, and many people told me, why do you put this delay inside if you want maximum speed? You should get rid of it. And I did get rid of it later in the later versions, in version C and D. And then I switched. This is the big difference. Then I switched back what I put to output. I put back to input. And remember, I've already put to input everything here. Every pin on this MCP, this chip, this MCP chip from my board, which is this one. So every in-out pins. It has 16 pins, so from 0 to 15, all its 16 pins are already set to input from the beginning. I switched to output only the ones that I need, and then switch them back to input, and everything is on input right now. Nothing remained on as an output. And this is it. This is the logic of this version of the program. And now comes the code optimization. But let me present first the other programs to see the evolution, how fast everything is moving, and how well is working. So this one, what I did here, I commented out these guys, and I looked closer in the with more attention in the library of this Adafruit MCP header, like from GitHub. I looked closer, deeper, with more attention in that library, and I observed. Actually, my attention was. I was influenced to look more closer to in that library by the guys from Arduino forums, and those guys actually influenced me to actually stay on and take that library a bit more more seriously, and I did. And I discovered this. Originally, I didn't know. No. This is the course. This is the write GPIO. General pins, it means GP, it means general pins, in, out, IO, and port A. This is what is meaning, GPIO A. And pretty much everything that I see the same, on the port A or B, I write a single byte of 8 bits. So these are on port A, and this that is on port B, which is pin 10, I leave it single like this. And let's upload it. So this is the big difference, and the big difference in code, but also in speed, because this is all done for speed. Let's upload it. Let's send it. So and now it's flickering, but the camera is blurring, and you see it's as stationary right now. But I hope you can see the flickering. No, it's not. But it's flickering visible right now, like a vibration. On the camera is looking like it's stable, but it's not that stable. Let's see if I'm moving the. Yeah, you can see the. If I'm moving the camera, you can see the some steps in it. But in reality, with the naked eye, I can see the pass from each line, from one line to another, how it's passing. So this was not good either. It was good, but not good enough, So this is version C, what we have right now here. Let's close it. And the final version is this, version D. What I did here, after I looked a bit more closer, and I effectively missed this. I fly over this function inside that library. I didn't see it. I actually didn't see it for some reason. I thought it's too complicated, and my brain skipped every time over it. But after reading every line there and paying a lot more attention to every detail that was in that library, I realized that I can write on a single line of code the both commands. So here, yeah, I have 3 low, this 3 low, and this is high. It's the same code as before, and this was the only port A that I commented out. I leave it there, and this is 2 bytes, so 16 bits. It's a bit more complicated to write. You have to pay more attention like this, in this form, but it's the maximum code optimization that you can do, and is working. And it is exactly what I did here. You have to write, here is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 16. Actually 15, starting from 0 and ending to 15. And that's what we have there, but translated here in binary. This is directly binary command, what we are seeing here. And here is what one guy correct me, because I made a mistake, of course, and told me that be careful, you have to start from right to the left, and to write those pins. And the rest is the same. Okay, so I commented all the delays, and every delay is commented out. as you can see. I did some tests with this delay open and this delay commented excluded. When you comment it, you are excluding it from the program, and it's when is one, like I said, when is delay is equal to 1, it's at minimum, or commented out is really no big difference. But in this particular case, it is a little bit of difference. So commented, if I comment it out, probably it did affect it with 1% or something, very little, but it did. If I'm switching to higher time delay, then it counts. It matters. This actually is the better option, to comment it out or not include it at all. But I keep it there for the testing purposes. That's it. But this is the best way to not include it in your program if you want the best speed and the higher speed that it can deliver. So right now, let's upload it. Let's send it. And yeah, but unfortunately the camera doesn't really shows. I really hoped. And yeah, on this one you can see how everything is passing, but it's a bit faster than the other version before it. The flickering is still visible in reality with the naked eye, but is way more faster. The flickering is like all at once are turning on off very quickly. Right now, this is the impression that is giving me with the naked eye. Here in the on the camera is showing like some LEDs are opening, but in reality, no. It's way more better like this, and way more optimized than the previous version. So this is the best version with all these 2 bytes or 16 bits sent at once. To everything. This was not my idea. I was helped by the guys on Arduino forums, which I thank them very much. So the next thing was to explain is how I use this library. So here in Arduino, I'm not sure. Yeah, I think I can show sketch. No, where are you? Manage libraries, yeah, and here that's MCP23017, and this guy is installed that I have here. Actually, I have another one installed. Let me show you. This one. Bertrand Lemasle or Blemasle, and I looked on the name here, and it helped me to identify the correct library. But this is the first library that I installed, and with this I worked so far. So how to get this MCP this particular library is you install it from here, from this library manager inside the Arduino thing. And on you Google this entire name, and you will get very close, and you will reach this page, this GitHub page, where this is exactly this library that I have already installed and I was working with. And as you can see, let's see, probably. Yeah, when you open it the first time, it will look like this when you open it the first time. And if we are going to source, this is the root. This is the root. So this is this folder, and then this folder, circuit folder. And here we have 3 libraries actually, 1, 2, and 3. And I was looking on this that is like let's open it. So are these 2? They're like a base, and here you can see a lot of stuff. Read GPIO that write GPIO. This one I was using in the very beginning without any port specification here, GPIO A or B, and I was seeing only this here, the GPIO A or AB, wasn't is not here in this library. It's only this basic function that we see here, and this didn't. I mean, it helped me, but this was the only good function that I could use. I've also tried everything else that I thought. Pin mode I tried, but I was getting the same speed. Digital write, this one, and write GPIO. These three functions, or maybe more than this. And here is the same. No. Which one? This one and this one. Yeah. Here is the name. Also x6, the base one, the base function. And here are more explanations for each of it. And for each pin mode, what it does, digital read and digital write. Here, brief, very good, very well explained everything. So what is high and what is low. So this value is either high or low, and this pin parameter is the Arduino pin number. Actually, it's not the pin number of the Arduino. Is the MCP pin number there. Digital write and write GPIO the same. Value pin states to write as unsigned int of 8 bits. This is what it means, unsigned int, and you will see it. And this is port 0 for port A and 1 for port B. And I did use this actually. So you have here on the port, you have to put 0 for port A or 1 for port B, and the value you have to put the pin number that you want to be switched. So this was the bad and not so helpful. I mean, it was helpful to a point. But the speed wasn't, I couldn't increase it. But then after the guys from Arduino forum suggested I should use this library, which is, let me show you here. So I was using this too. This two I was using. I was looking intensely on this two. But I ignored these two, which are a bit more advanced, and they actually helped the code to get at the stage it is right now, the maximum speed. And here, this is like a summary. It says, I really, yeah, so this is GPIO A, port B here, for 8 pins, for 8 bits. And this is the one that I literally skipped. I didn't really see it. I had to look multiple times until I see it. GPIO AB. And you see here is 16 bits, which is 2 bytes. And let's see the actual function here. So this is GPIO A, and it's really simple to use, but you have to know what to do there. Returns current pin states of port. This is read, right? The right ones we are interested. So it writes to GPIO A automatically. This is using that GPIO value to 0. You remember from the base function, the x66 function, and is using that thing. And here is using is renamed as GPIO A int unsigned int of 8 bits. I have to put a number of 8 bits, and read again, write, and this is for port B, and is switched to 1. As you can see, it's exactly that base. Basic that we've seen before, and this was the salvation. This is read. Sorry, this is the write function, and it says here A and B is 16 bits, and it says here this is the internal of the function, what it internally is doing, and is writing to I2C protocol or SPI protocol. There are 2 protocols that you can write with the same function, which is good. Is using that basic function from the base library, the x66, and also here the x66 is the base. So get register 0 and 2. I'm not sure here what is doing. It's a bit too high level for me, and is writing these values to those 2 ports at once. And which is absolutely time saving from the perspective of communication. It's very, very fast this way. to write to both ports at once. So this is the code that I use, the code optimization, the library, read of the library and choose the right functions inside it, and is exactly what you are seeing here. GPI. This is the first A, and this is AB with 16 bits, and pretty much this is it. I mean, I think I covered everything. And better than this is to use dedicated chips that are doing it in hardware. All of these are doing it in hardware, but for this exercise that I did here, just to see if this module, if this LED matrix component, this is a component. So all I wanted to see is this component working, and what it takes to make it work, and how to make it work, because I didn't really had any helpful. The internet didn't help me for this specific component. I get results from other components with other pin numbers, other way of they were linked different way, and they didn't include the resistors. I had to figure it out by myself that because they are LEDs, they definitely need some resistors. And if they, I imagined maybe they had they are already have internally a resistor probably, but I didn't want to risk it, and I put resistors anyway outside of them. Right now are 300 ohms resistors. I switched them from 1 kilo because when I increased the speed, the LEDs got very extremely dim. If I was putting daylight on top of this component matrix, you couldn't see the LEDs open, only in shadow. And right now is not very brightly lit as well, but is a bit more brightly lit than it was with 1 kilo per each resistor. So by decreasing the value of the resistor to 300 ohms per resistor for each of them, it got a little bit brighter, and it's a little bit better. But to bring each LED to its maximum, you have to do some hardware trickery that I probably am able to do it, but it's a lot more hard work to do it, and it's really not it's not in my interest right now to do it. But if it needs, I have to do more hardware trickery to boost the current and even the voltage probably of the LEDs. So yeah, this is it for everything. I hope you understand how to work with libraries in Arduino, specific libraries, code optimization, how important it is, and pretty much this and speed, basically to improve the speed of your device if you have this kind of problems like I had. So this was a test program. I was playing around because I had this component and I had to test it, and this is the best way to test it with software. So yeah, maybe I will make a full program with every letter, but nah, I don't think so. Okay, this is it. Thank you very much for watching, and I hope you like it. And leave a like and leave a comment, and see you next time. Bye bye.